Today in geometry, we're going to spend our second day on 11.3, perimeter and area of similar figures. Today we're going to focus on when they don't give us pictures, but they give us everything in word problems. So number one, the ratio of the areas of two similar figures is 9 to 25. And the ratio of the corresponding side lengths, scale factor, and the ratio of the perimeters. So this is kind of a review from yesterday. So they tell me that the ratio of area, 9 to 25. And the ratio of the corresponding side lengths, so the ratio of sides, remember I just have to take the square root of the area. So the square root of 9 is 3, the square root of 25 is 5. The scale factor is the same thing as the ratio of sides, 3 to 5. The ratio of perimeter is the same thing as the ratio of sides, 3 to 5. So this is just to remind us that all three of those are the exact same thing. The ratio of the sides, the scale factor, the ratio of the perimeters is all going to be the same thing. All right, number two. Triangle ABC is similar to triangle DEF. The base of triangle ABC is 12 centimeters. If it helps, let's draw these triangles out. So ABC. The base of ABC is 12. So now I have D, E, and F. The height of DEF is 60, so I'm going to put that as my 60. And its area is 1440 square centimeters. Find the area of triangle ABC. So first, I need to find the base of this one. So I'm going to call this base, right? Because I don't have corresponding side lengths. But I know how to find the area of a triangle. So area equals 1/2 base times height. I know the area is 1440 equals 1/2. The base is what I'm looking for. The height is 60. So I have 1440 equals 1/2 times 60, 30b. Divide both sides by 30, and I find that the base is 48. Right, so we found that our base was now 48 here. So now I can go ahead and find a scale factor or a ratio of sides, ratio of perimeters, whatever we want to call it. So if I start with a small, 12 over 48, because now I have my corresponding, that is going to reduce down to 1/4. So the ratio of my areas, I would square that, 1/16, set that equal to my area. I'm looking for this area over 1440, the area of triangle DEF. Cross multiply, I get 16a equals 1440. Divide by 16, so I get the area of triangle ABC is equal to 90 square centimeters. Let's try another one. Number 3, triangle ABC. Again, if it helps, draw them out. ABC, triangle DEF. The height of ABC is 30 inches. The base of DEF is 8 inches. Its area is 40 square inches. Find the area of triangle ABC. Again, I don't have corresponding sides, so I need to find the height of triangle DEF. So my area, 40, equals 1/2 the height that I'm looking for times the base. So I get 40 equals 4h, so my height is 10. So now I have corresponding, so I'm going to find my scale factor is 30 over 10, or 3 to 1. The ratio of the areas then would be 9 to 1. So now 9 over 1 equals the area I'm looking for over the area I know, 40. Cross multiply, I get A equals 9 times 40, 360 square inches. All right, now let's throw a rhombus in here. Rhombus, VWXY, so, and rhombus, so VWXY. Mine look more like parallelograms right now, but that's all right. RSTU are similar. The diagonals of this first rhombus are 18 and 24. The area of this other rhombus is 384 square feet. Find the lengths of these diagonals. can find the area of this rhombus because I know that my formula for area of a rhombus is 1/2 the two diagonals multiplied together. So 1/2 24 times 18. So the area is, let's see, half of 24 is 12. 12 times 18, 216. So now I can find the ratio of my areas is 216 over 384. I can simplify this. They both have a, let's see, 24 in common. So that's going to reduce down to 9 over 16. So now I can find the ratio of my sides. Remember, I take the square root of the area, so it's going to be 3 to 4. So now I can set up my proportion, sorry. So 3 to 4 is going to equal, pick one of the diagonals, and it doesn't matter which diagonal I pick, so I can pick 18 over diagonal 1. And then 3 to 4 equals, over my other diagonal, 24 over diagonal 2. So I'm going to cross multiply, so I get 3 times diagonal 1 equals 4 times 18, which is 72. 72 divided by 3, I get diagonal 1 is 24 feet. Cross multiply over here, 3 times diagonal 2 equals 4 times 24, which is 96. Divide by 3, and I get that diagonal 2 is 32 feet. And again, it doesn't matter which one I call diagonal 1 or which one I call diagonal 2. All right, let's go to the back. This is find the scale factor and the ratio of perimeters for each pair of similar figures. Triangle ASR is similar to triangle NTC. They give me the area of, they give me the area of both of them. So the area of ASR is equal to 8 square roots of 3 meters squared. The area of NTC is equal to 128 square roots of 3 meters squared. This is just written twice. Okay. So I want to find the scale factor. So take the ratio of the areas, 8 square roots of 3 over 128 square roots of 3. I see that my square root of 3's cancel each other out, so I have 8 over 128. I can simplify that down to 1 over 16. So this is the ratio of my areas. So then that means the ratio of my sides, take the square root of both of those, that's going to be 1 to 4, which is the same thing as my scale factor, 1 to 4. The ratio of my perimeters is also 1 to 4, all the same. Number 6, find the values of x and y when the smaller similar rectangle shown here has the given area. I can find the area of the bigger one, 10 times 9, 90 square feet. So now I can write the ratio of my areas, right? So the ratio of my areas is going to be 10 over 90, or reduces down to 1/9. So now I want the sides, so I can find the ratio of my sides is going to be 1 to 3. Set up my proportion, so 1 over 3 equals, if I find x first, that would be x over this side, 9. Cross multiply, I get 3x equals 9. Divide, x is equal to 3. So x is equal to 3 feet. I could do the same thing to find y, so I could say 1 over 3 equals y over 10. So 3y equals 10. So y equals 10/3 feet. I did the last one for today. The figures in each pair are similar. Again, it's the same thing written twice. We don't need it. And the value of the missing side, triangle BEV, is similar to triangle SEF. So the area of the great big triangle is 36 over 12. So I can find the ratio of the areas is 36 over 12. I can simplify that down, right? So that becomes 3 to 1. B to V is 6. I'm looking for S to F. I'm going to call that X. So this was 6. So this is the ratio of my area. I don't want to find the ratio of my sides necessarily, because if I do that, then I'm going to have the square root of 3. If you don't mind working with the square root of 3, then that's fine. So I can go ahead and just do the ratio of my area, 3 over 1, equals, so then remember I can just square these. So 6 squared, 36 over x squared. And then I won't have to deal with the radical to the very end of my problem. Cross multiply 3x squared equals 36. Divide by 3, x squared equals 12. Take the square root. That's not a nice whole number, but I can do factor tree. So 4 and 3, 2 and 2. So x is equal to 2 square roots of 3 square meters. So SF equals 2 square roots of 3 square meters. So that wraps up day 2 of 11.3.